Hello, everybody. Nice to see you here. The subject given to me was actually a sort of idea of Eurostat, so I blame everything on Eurostat. And from sort of personal and business perspective, the subject, this IoT ecosystem in the hands of national statistical offices, that really scares me. And I'll show you this elephant, why it scares me. It's a huge thing. The amount of gadgets actually surpassed the amount of people on the internet already years ago. They are generating data about, it's a link, so afterwards you can click to this source of this ecosystem picture. It explains the ecosystem of IoT and all the different layers. It's a very good source for learning about the ecosystem that is currently happening, that is moving fast. And for me, what I said, I'm scared because I don't see the perception of change in national statistical offices. Statistical offices are used to deal with data where the statistical unit, being a person or a company, has some records per year or per 4 years. And now suddenly we are getting data from different directions about the same statistical unit, about connections between statistical units, people, assets, companies, on a much, much faster and more detailed scale that is basically giving, if we approach this situation from the perspective that we are used to, we are basically standing into the shoes of the big brother. And that's what scares me from business and personal perspective, because I don't yet see statistical offices being voluntarily opening up themselves, becoming transparent to the data subject, and also sort of accepting external control. I myself am a statistician by education. So we got this ingrained that yes, we are very ethical, we perceive secrets, we perceive privacy protect as statisticians. But currently we have not yet got to terms with this power that all this data actually gives to us. And we also haven't found this place and approach to this IoT ecosystems. We are looking at this elephant. We are looking, okay, it has a nice tail, it has some trunk, it has some eyes, some ears. We are going and touching it from different angles, but we yet cannot approach it really in perceiving the wholeness of the ecosystem. And also, what are the design principles? When I take a couple of steps back from the system, there always have to be engineering principles by which we design the approach. Either it's the organization, how do you approach that ecosystem? Do you approach every individual data source? Do you approach the evolving data markets? Do you approach, sorry? Okay, better. Do we approach every individual governmental register? Who are our friends? So basically, what kind of organization are we designing? How are we designing security into it? I started from IoT and knowing that all the gadgets are very low-powered. They have low low computing power, and the engineers and managers who have designed these gadgets are not very good at security and privacy. So actually, we have a growing security and privacy problem that is sort of like overrolling us. What are we doing to sort of approach that problem? And to make the situation even more complicated, the tools that we have been using all the time, all the SPSS, SASE, status, well, they were designed for this old time when we actually had a perimeter. We took data into our building, we analyzed it in some secure environment, and there was clear border. But where's this perimeter in the IoT ecosystem? There isn't any. So basically, our approaches, our tools, our design principles, they all need to change. One of the difficult issues with designing for privacy and security is that this wishful thinking that, okay, I have something, so please come and make it secure and private. Actually, it doesn't work like that. So basically, systems need to be designed from ground up by principles of to be secure and to be private, privacy preserving. And actually, I see that more and more when I talk with statisticians, this message is becoming heard. It's not very popular yet because it messes with the status quo. It sort of questions our design principles, our current being. Little example that one of my colleagues brought, and the funny thing was that when I was coming back from an event where I had introduced that little principle, my taxi driver was complaining that he had bought a flat, and when he moved into that flat, he couldn't hear all about the neighbors. That was a little bit too much for him because he was a private person. He didn't like to hear all the details of neighbors' lives. And actually, well, walls work both ways. So it was the same for him. He had a privacy problem. So a privacy problem, when we identify it, is rather costly. So what do? We exit, we sell it off, and it's not our problem. We need to redesign, or we just sort of suffer and try to tolerate the problem that we have. Usually companies or organizations start redesigning systems. When designing for privacy, there's a very nice standard knowing standardization work, who has participated in creating or writing standards from this audience? Okay, a couple of people. Well, international standards actually are very long consensus processes. They usually take like 5 years of different organizations, different nations discussing the practices. And it's like this consolidation of the best practices of the terms about talking about a problem and designing in this space. So I would definitely argue for everybody in statistical offices who is responsible for systems design or who is ordering their employees or partners to design statistical systems to actually read that standard from 2013 because it has really nice examples. It has all the different principles that currently in Europe are also crystallized in GDPR as well, inspired by privacy by design and by default. And there's an actual ISO standard for that. So please do read that. And, well, not just scaring people, actually maybe giving some ideas, what can we do very easily differently? In some business areas, algorithms, here we are talking about trusted smart statistics. Trusted means that actually we have developed, published, and agreed about the methodology that we can currently consider best practice. So that's this trusted algorithm part. So this has been going on in different areas where just the data sets are becoming so big that they have their own gravity. You cannot move something that is really, really big sitting in some biocenter and that is hundreds or well, in terabytes. It just doesn't move. It's like a big tanker. And you send algorithms to the data. Very simple thing. Everybody can do it. And then also the next little tool, computing in encrypted form. It has been, the theory has been around for 30-something years. Nowadays, already the universities are complaining that there are so many of the frameworks around that when they open the search tools and start searching for alternatives, they basically have to renew what they know about the world every month. And there are a number of different nice comparison articles about the tools and also about using them in solving real privacy or confidentiality problems. Eurostat and the SS network is really good at cooperating. When I first met what was going on in United Nations on a workshop on sustainable development goals, I actually brought them the SNET cooperation and sharing best practices, methodologies, and experiences as a best practice. But interestingly, when we started talking about cooperation with different statistical organizations all over the world, it was actually ONS from UK. Anybody from UK here? No? Okay. Here. Hello. And They came to us at the beginning of last year, and it ended in us presenting some use cases on best practices from New Zealand on the official statistics. It's this United Nations global data platform that is my recommendation also for the European statistical system to not just sort of be regional, but actually open up, because this IoT ecosystems, they're not just Europe, they're actually global. And the phenomena that we are measuring, they are not also bordered by country borders, they are global. I'll quickly run through 3 use cases as an examples. Estonian statistical organization is using smart metadata. But where do they get them, this data? Currently, there's an active data market that the electricity distributors have created for themselves, just like Amazon basically, to support their own activities, in the end came up with Amazon Cloud Services and started offering for everybody else. This company is now offering the service to like consumers, me. I can go and compare my electricity consumption. I can offer my data to apps. I would suggest that this is a really nice place for a statistical organization to go and also become a consumer of that data. This use case with United Nations, it has all the grains of this doing stuff the right way. The methodology comes from New Zealand. The experimentation was on synthetic data. The deployment was on this United Nations World Data Platform. And actual deployment happened physically in Europe on 3 different public clouds. And the study question that can be computed based on this the methodology. It's FUSE. The name of the methodology is FUSE. F-E-W-S. It's about calculating consumer price indexes based on, confidential business data. Well, imagine, for instance, different retail stores. They wouldn't like that the neighbor or competitor would know the pricing, or for instance, consumer goods company X, like Coke, would know exact pricing of Pepsi. But when the stats offices gather that information together, all in the statistical office, to do the regular price index calculation, it actually becomes a business threat. And it becomes a valuable asset that also intruders outside, or some Snowden guy inside, might be very interested to utilize. Another example, location data. We all have smart sensors sitting in our pockets. This data tells a lot of interesting stuff. It can, for instance, measure also the number of tourists in a country. And the use case that I'm bringing, this is now real country, real data, and actually using these 2 principles that I brought out. Telecom operators doing their own sort of statistics locally, giving the results to Ministry of Tourism. But we know then there's the question that, okay, we are coming to a country, say Indonesia or Germany, I'm not fixed to one operator, I'm jumping between operators, so what's the overlap? Then come in secure computing, and this very nice little task that it did is it calculated the correction coefficients for different district that the different operators had seen the same roamers. So basically, from the operators, you get the uncorrected estimates for tourists by countries. And then from this private intersection, you get the correction coefficients. So you know how many unique tourists came into the country. Very simple. So I think that's basically it. The gist of my presentation was that do think about designing systems for privacy and security. Think who might be your friends in this evolving ecosystem of IoT, and please, please do cooperate larger than regionally.